you're looking for the area of the favorable over your total.
There's still 12.3, Mr. Moore?
Yeah. Over the area of the total. Okay. Now, if I want to look at, I'm going to look at geometric probability as well as taking it a step further into kind of what we're looking at more into tomorrow, just so you guys get the idea of where what the next ideas are as far as like the wording and stuff is considered. Up here you've got a bunch of circles embedded in a square. And let's say I want to get the probability of getting 2 points. On the you can see how this is 5, 10, 2, and 0.
Oh,
Each one of those values are the point values of landing in the spots. So if I want to find the probability of landing in getting 2 points, what would be the what would I do?
Well, you have to find the area of the whole circle, and then you have to find the area of the green circle and subtract that, and then you have to subtract. You have to find the area of the square.
Right. Question. Yeah. Stop the clicking. Okay. So if I'm going here, what is the radius of the 2-point circle?
It's 3
inches.
Well, it's 9.
9.
How is it 9?
Because it's all
3
equal.
plus 3 plus 3.
Seriously? Seriously. It looks like it's just 3 on the way.
There's 3 arrows.
Like they're really proving the point that that's 3.
Yeah.
So it tells you that the radius of that one is 9. What's the area of the circle if the radius is 9?
9.
It's 81 high.
Okay.
81 high. High are squares, so 81 high.
But what do you have to subtract out?
The green circle.
So 6
The green and the red circle.
Yeah.
minus 36.
It's a 36 pound.
So you get 45 high.
Yep. Exactly what Catherine said.
And then what's the area of the square?
It would be 6. It's a square. Given it a square. So you have 6 times 6 is 36.
Oh, 9 squared?
Wait a minute.
Well, it has to be a square. 18 squared is 3.
You're right.
Because the diameter would be 18, which means that's the side.
Oh, I know.
Okay.
Oh, I'm getting kind of confused.
Now, when you're putting this up in your calculator, make sure that you type it in with the fraction bar. The radius here is 6. Okay.
That makes sense.
So in the calculator, you have 45 pi over 324, and it gives you some decimal value, which is
0.436332.
4.
Yeah, 4. That's right.
Okay? So your geometric probability of landing the 2 points is 0.44. Okay? All right.
And that's if, like, there's no.
I'm listening.
So that's if, like, there's no possible way you're going to throw the dart off the board.
It's
If you hit it on the board.
stop being so overly critical.
But you're gonna hit something.
Yeah, we're looking at just that value. Okay, that's gonna happen. All right. I know where you're going with that, and that's I get it. Yes, ma'am. That's fine. Decimals are fine. Most of these aren't going to give you.
Slowly.
Most of these aren't going to give you a very clean fraction. Okay. Let me ask you this then. I need a quarter. Who's got a quarter? Your quarter. 9 18 squared. The side length is 18.
I got you. No,
I don't need a spring. I just need a quarter.
Well, it's actually from my seminar.
All right. So we have heads and a tails and a quarter, right?
Yes.
So we have. What is the probability of flipping a coin and having it land tails?
75.
50.
It's 50. Okay. Now, if I want to think about this in terms of a compounding event, each time I flip a coin, is it a specific event in and of itself? Each time you flip a coin, it's its own event. Okay. So what's the probability of going tails, tails?
25%.
25%. It's 1/4.
And then we.
Because each individual trial is its own event, and when you have independent trials, you're going to wind up multiplying
So
them
then we
together.
have 12 and a half, right?
So you have 1/2 times 1/2.
5.
So if I want to go tails, tails,
Wait, no.
Yeah, I mean, like, that made sense, like, logically, I was like, yeah, you would have a 25% chance, but you're like, they're each separate events, so you don't do it.
so if I flip it,
Heads.
it's tails. Woo-hoo!
What?
I try again.
Heads.
It's tails. Woo-hoo!
Are you lying?
No, I'm not. It's tails. I'm not lying. You can verify. Okay.
Tails.
Now, what is the? If I go again, it's going to be 1/8, right?
Yes.
Yeah. Heads.
Tails. Woo! I win it. You can stand here, Claire, if you want to believe me.
Now you have a
You're going
point of
to-
All right.
6.5.
Now it's 1/16.
Heads.
Woo-hoo! That was tails. I swear. I swear it was. It's still tails.
Another 32.
All right. So that's 4 in a row.
It's working.
No. So I got 4 in a row. Okay.
Or I'm
Now, I didn't get 2 in a row.
First time.
So what's happening is each time that you want it, you check it, it's the probability multiplied out each time. So let me think of it this way. I'm going to ask you guys, what is the probability? Let's take this under a separate screen. What's the probability of 2 bullseyes in a row?
Wow, you have to go through a lot to figure it out.
I want to know the probability of getting 2 bullseyes in a row.
Oh, so
Oh, I need to do some math.
What's that?
Are we gonna find what one bullseye would be and then divide it by 2?
No, I don't.
What?
Here, you ready?
Oh my god, that's scary.
That was really bad.
Yeah.
That was kind of
scary. How did you do that?
How'd you do that? Give me a quarter.
I don't have a quarter.
I have another.
Just throw it back, just throw it back.
You're gonna like hit Allie with that.
Would you throw 2 of them at me?
That was awesome. I pulled out another one.
Oh my
How do you
gosh!
do that?
Do that again.
What?
Hey.
It's like hit it like pops. How do you do that?
I found out the answer.
How do you not know how to do that? If you guys never had, you know why your generation doesn't know how? Because this happened in 3rd hour too. I was flipping coins and hopefully, you guys got this. You had 9 pi over 324 times 9 pi over 324. It was like 0.007 something, 76?
Yeah, well, you multiplied it by
Wait,
2.
the bullseye is
Oh.
Yes.
Yeah.
Multiplied by, I multiplied by I'm
You're not multiplying by 2. What's happening here is you're taking each time you want to get a bullseye, it's its own event. You're not, you're squaring it, okay?
It's 3 squared. That's
It's the same idea as you're flipping a coin. It was 1/2 times 1/2 times 1/2 times 1/2 each time. So you're just changing the exponent, if you want to think of it that way. Yes, sir.
So wouldn't that be like the same odds as if you were to just hit like the tan circle or just hit because it has the same actually, and then you subtract to maybe no never mind because it's not a circle so you can't use it.
Okay.
Yeah.
I'm not exactly sure what you're talking about, but I think you might know what you're talking about.
I know what I'm talking
Oh my gosh.
So remember, and this is more of the stuff we're going to start to look at tomorrow as far as multiple events that are going to occur. Let me look at another one though.
We got really off topic the other day too.
We never get off topic.
Never. We're always learning diligently. Shade.
I'm going to look at the probability of the shaded region.
No.
What?
I'm going to do the probability of the shaded region.
Do you have to find like the area of it?
No, it had nothing to do with this.
That was such good sarcasm.
Wait, what that was?
So, a couple things to look at here. What is the shape that's not shaded?
It is a
Rectangle.
rectangle plus a triangle, which is a rectangle.
A triangle. You know what? I mean, it could be.
That's a what?
I can still hear you.
What is the shape of the non-shaded?
Oh, the non-shaded.
Oh, right.
It's a rectangle.
Thank you.
I mean, either way, the answer is still a rectangle.
No.
It's a rectangle.
Do you see right angles anywhere on the triangle?
No.
Wait, no.
So can you assume?
No, yeah.
Can you assume that it's going to be a rectangle?
It's not.
You're right. You can.
Oh, wait.
But if you look at the triangles, the two triangles themselves, will they be congruent?
Yes.
Yeah.
Because of why?
The tick marks.
The tick marks, side, side, side. Okay. Now, specifically, if I'm looking at the triangles, the triangle.
How is it still going?
We know that this is happening.
Yes.
Do we have a vertical height anywhere?
Yeah.
Yes, it is 12.
No.
No. But you can just.
Oh, you have to split it in half. So
I can draw a line and make one. Now, let's see what you remember. This is an isosceles triangle. Do you agree?
Yes.
When you draw the height of an isosceles triangle, it creates the right angle. What does it do to the base?
It splits it, so 6, 6.
Yeah, 6, 6, but what do you call it?
It bisects it, yes. When you have an isosceles triangle, when you draw from the vertex between the two congruent pairs of sides, it always is the perpendicular bisector of the third side. It's one of those rules that you guys had last year in geometry.
Does it make those, this might not be related, but does it make those bottom
Yeah, yeah. We're trying to find the height. Yes, ma'am.
And I will use the diagram.
Yeah, that's exactly what you do. At this point, you just use Pythagorean theorem. So you get
8 squared.
64 minus 36
You get the square root of 28.
2 root 7.
I get what you're saying.
So you get 2 root 7 for the height.
Yes.
Where's what come from?
Like, you just did that. No thought at all.
Well, because this is
Well, I mean,
28.
I know now, but like, my brain, I was still thinking like, okay, it's isosceles.
So we know that the height here is 2 root 7. We're okay with that.
Yeah.
Move your foot.
How many of these triangles do we have?
Whoa, what just happened?
We have 2 of them. I'm looking at just 2 triangles and a rectangle. Now the overall shape, or excuse me, the overall area, what's the area in here?
It's
48, good. We know that's going to be 48 something squared because it's 12 by 4. The triangles then have areas of 1/2 the base, which was 12, and the height of 2 root 7.
So
And
it's
how
6
many of
times
them do we have?
So we have 2.
And we have 2 of them.
So it has 12.
This is like just
together.
It is. I'm taking this problem from geometry. So I know then my area of the favorable region. Give me 1 second, Christian.
I was just gonna ask if we're gonna do it with 3D sheet.
No. My favorable region is going to be the 24 root 7. My overall region is going to be the 24 root 7 plus 48. Okay?
The 24 root 7.
The 24 root 7 is the area of the 2 triangles.
Oh, yeah, I got it.
And then the 24 root 7 plus the 48 is the 2 triangles with this with the rectangle thrown in. So when I put that all together, what becomes my probability of landing in the shaded region?
48.
No, that is addition.
You're just full out.
I was going to go that harsh.
0.569499126.
Snap pennies at her and call it a day.
So it's
I'll
0.57.
provide the penny.
Throw the tape roll.
Which is about 50 cents on
Outside the
the
dollar bill.
Anybody else get about 0.57? Make sure when you do this, use parentheses, use the fraction bar. Too many people try to do it all at once and hit divide by, and it just doesn't work. Okay? Because it's not as clean. The calculator isn't that smart.
Not quite.
Oh, that was
I'll send the geometry.
geometric probability of landing in the shaded region.
Very small.
Very small.
Yeah.
Boy, you are SMRT.
You need to get the approximate.
That's funny because I do have a name. Time changes.
It's still early in the semester.
No, it's not. We're like
We have like
3 weeks away from
Wait,
finals.
no, I'm gonna do mine.
We have 19 days
Oh,
of
no.
teaching.
I have to hold this.
Oh,
Very sad.
Hold it.
I have a bad year in
I
grade.
In this case here, does everybody agree that you have a circle with a hexagon inscribed in it?
Yes.
Christian, put that paper all the way, please.
Yes.
Now, one of the things that I want you to remember about a hexagon, this is one of the reasons I put this one up here, is that you will have to use the perimeter apophyte. But, one of the things I want you to, what are the properties of a regular hexagon?
Oh my.
Remember, when it's regular, it has to be regular because it's inscribed in the circle.
And it's got the 36
It'll have a whole bunch of stuff. We know that all the outer edges are the same. We know that all the sides are the same. We know all the base angles are the same.
What are base angles here?
They are. All the base angles are 120.
Are we going to know that?
You have to remember how to find it.
It's on
N minus 2 times 180 over N.
Wait. N minus 2 times 180. Wait, is it?
It's 180.
Oh, hey, there. That's gonna be.
Wait, 180 n minus 2.
It's literally right there.
Wait,
I just learned that.
I remember last year in geometry we learned this at like the end of the year, so is your geometry learning this right now?
Yeah, they're working on it right now. Now, what I want to show you is that if you draw in the radius specifically within a hexagon, we know that all the radii are the same too. Do you agree?
Yeah, great.
One of the other things that happens when you have a regular polygon is that no matter what, you always get this scenario. I draw this up for all regular polygon style problems, whether they're 5-sided, 6, 12, 15, doesn't matter. There's always going to be 3 sides in a row with 2 angles. The apophyte is always perpendicular bisector of one of the sides, and always there's a radius drawn to a vertex. This diagram allows you to solve any regular polygon problem. Because if I know just a little bit of the info, I can fill in the rest. For example, in this case, we know that the radius is 7. We also know that the large angle is 120,
So 60.
which means this one is 60.
30, 60, 90.
30, 60, 90.
So what is your apophyte?
Hang on.
Just a second.
Well, this is just a question. If it's not 30, 60, 90 or 45, 45, 90, do we use your grade?
Yep, it's usually tangent.
All right, it would be, well, across from 30 is 1. So, yeah.
So the apophyte would be 3.5 root 3.
So it's
Because across from the 30 would be 3.5.
Because it's half is 7.
Which means this side is
It's
3.5.
x and 7 is 2x.
Right. Which means the whole side length is how much? Anytime you have, this is the only case that this happens. Regular hexagon has the same radius as it does sides.
Always.
The sides and the radius are congruent in a regular hexagon, always. Because you wind up with 6 congruent equilateral triangles.
Oh, yeah.
That's why that works. Because all of these angles are bisected, you get all these 60-degree angles. So you have all these equiangular, which means they're all equilateral.
Yeah.
That's why that works. I just wanted to remind you of that with the hexagon. Not with all shapes, just the hexagon that works. Yeah. If they're in a circle. Ones we're looking at, we're only looking at regulars. Okay?
Wait, what's the
Rhombi. So the area of the circle would have been 49 pi. Subtract out your 1/2 perimeter apophyte. 6 sides times 7 times the apophyte, about 3.5 root 3. All over.
Wait, 6, 7, 6, 7, 7.
You just.
Why? Should it be? Oh, we should double it. Never mind.
Remember, all I'm doing here, guys, is I know that my side lengths are 7, and there's 6 of them. I'm not. Why press buttons twice, just do it all at once. Just put it all in parentheses and be done with it.
So you're finding,
Probability of landing in the shaded region.
yeah, and that like huge thing right there is finding that area of the hexagon because you're finding the area of all the triangles.
Yep. Okay. That's how that one works.
That's easy.
Then let's change it up a little bit.
Oh, this is like a flashback to ISATs.
I know.
I love this.
Let's find the
We
probability
did this on the Explorer.
of the unshaded.
That's like something.
Unshaded.
This makes me.
Let's find the probability of the unshaded.
So it's all those circles.
So one circle has a diameter of.
So we have unshaded, so it would be 12 by 8. Subtract out 6 circles. Each circle has an area of 4 pi. Sir, how do you find a radius? If this is 8, each diameter is 4, therefore each radius is 2.
And then we just put it over.
Okay? That's how those things work. Let me give you some of these to work on tonight. It's geometric probability. It is a geometry whoa. Wait, Pointer Sisters. I know. I just can't hide it.
Earlier, I wrote that it was 2013 on my paper.
Mr. Murphy,
I was so thankful that it was wrong.
like if I raise when we have to see what happens in the motion shading, we're just like dump it all out.
Dump it all out and start chucking it at each other. On this one, let's do this. What do we have? 5 through 8. What did I write down? 15 through 17. And then I want to do, what is it, 22 and 23? Yeah. These are all geometric probability. Do on a separate sheet of paper because you have a little bit of space. Tomorrow we will talk about probability of compounding events. Shouldn't be that bad. We'll talk real basic stuff to begin with. I don't even think we'll even get to Marvel yet. We'll probably do Marvel stuff on Friday.
Marvel. Sounds awesome.
Where does this, okay, that's the
quite fun.
Tell me what feels like.